Hey guys, so I've been requested to demonstrate on YouTube how to convert a Hawthorne into a fischer structure for some of you guys. So this is just a real quick demonstration, really simple. I'll keep it as simple as I can. Okay, so let's just establish the basics. In order to get this ring structure, we have to have a reaction between the alcohol and the aldehyde. And as you guys can remember, this is just a hemiacetal once it reacts. The oxygen would want to donate electrons to this carbon, and hence you would get this bond here. Alright, now that we've established that, let's move on to question 1. So say they give us a hexagon, which they probably most likely will. So like this. I'm just going to make this up. This has no significance whatsoever. Not very good at my randomization skills, but that'll do. Alright, so we have a B structure, even though we want A's. Anyway, alright, so if we are given an example like this, right, you might be thinking, how am I meant to convert that into a Hawthorne? Well, you start off by looking at which bond you need to break. And obviously, from the example above, the only bond that's missing here is this one. That's the bond we need to break. This one. Alright. The second thing you need to look for is which carbon. So once you break this bond, the first carbon you see is this one, and the first carbon on this side is this one here, right? But you need to know which one becomes more oxidized, because the more oxidized one goes on top. If we break, okay, just think about it like this. If we break this bond, the 2 electrons would go to the oxygen, therefore leaving a carbon cation. This oxygen, because it's a carbon cation, will then donate 2 electrons to this carbon and get rid of the H. This will leave a double bonded O here. And we all know that aldehydes are more oxidized than alcohols. Yeah? Okay, so then you would get the O and the H. By the way, this CH2OH is exactly the same as this CH2OH. So if we name that 1, name that 6, then we can go around in the circle and name our carbons. So that's 1, 2, 3, 4, pentultimate carbon number 5, and 6. So that's our anomeric, and that's our pentultimate. These two are important. Alright, so now I'm looking at our fischer structure. We have 6 carbons in this side and 6 carbons here, so we have to draw 4 lines, because that's 1, 2, 3, 4, 5, 6. 6 carbons. I hope you guys get that. Alright, so the next step you're looking at is where to draw the OH and H's, and there's a simple rule that you need to follow. Basically, if in the Hawthorne structure, the thingamabob is pointing upwards, it's going to point to the left in your fischer structure. So if it points down, it will point to the right. So that's just a basic thing that you need to understand. So as you can see here, for carbon 2, 3, and 4, it's H, OH, and... Did I draw OH? No, I drew H. So H, OH, and H. So for carbon 2, 3, and 4, you have H, OH, and H. Alright, and then just fill in the opposite side, because it's always going to be the opposite. Alright, pentultimate carbon is a bit different. As you can see, it's not directly an OH and H pointing up or down, and there has to be some kind of a twist for this CH2OH to go to the bottom. In this case, you're looking at if the CH2OH is pointing upwards, like in this example, then the fischer structure has to be a D. And in order for it to be a D, as you guys can all remember, OH is on the right side. Write it? Get it? Right side? Anyway. Okay, so this is basically your answer. I hope you guys get this. Well, you do, because I have to move on now. Alright, so question 2. We've also been given pentagons, if you guys can remember, which also have 6 carbons. And this one got me for a bit, but now I understand how to do it, so I'll share it with you guys. Again, this is just random examples that do not mean anything, so don't memorize the exact structure, because it won't help you in your exam. It might, but probably not. Okay, so for this example, the same thing, you're going to break this bond here. That's actually connected. I just have no coordination. Alright, so that bond is broken. And as you can see, if you name these carbons, 1, 2, 3, 4, 5, and 6, Alright, so in this particular structure, you might be thinking it doesn't really matter whether you draw the carbon 1 at the top or the carbon 6, but it does, because the next carbon on is more oxidized than this next carbon on. And as you can see, this carbon here, if this bond is broken, exactly like the example above, the oxygen takes the 2 electrons and leaving this carbon as a carbon cation, then this oxygen would double bond, losing this H, and this would be a double bond. So in fact, this one actually looks like this. So for carbon 2, which is this carbon here, carbon 2, so it's carbon 1 and carbon 6. For carbon 2, all you need to draw is just the double bonded O. They do prefer it if we draw it on the right side. This is something right about it, I guess. And yeah, so that's 1, 2, 3, 4, oh, missing one, 5, and number 6. And then exactly the same rule applies. So you're looking at 3, 4. 3, 4 have H and OH, so that's H and OH. OH and H. And then for the pentultimate, same rule applies. CH2OH is on top, therefore OH is on this side and H is on this side. Alright, I hope you guys understand that, and good luck.